Welcome back to the last part of this section on fundamental identities. We've done a lot of substitutions so far, but now we're going to look at a different way to do substitutions. We're going to keep talking about identities, but in this case we're asked to suppose if x equals 3 tangent of theta. And then for theta in the interval from 0 to pi over 2, that means we won't have any undefined parts. And we need to rewrite the square root of 9 minus x squared in terms of theta. Well, if we know that x is equal to 3 tangent of theta, then we can use a substitution to replace the square root of 9 plus x squared with 3 tangent of theta. And now we'll square it. Now it is in terms of theta, which is what we were asked to do. At this point, we should probably check to see if we can simplify anything. And I have 9 plus 9 tangent squared theta, which means I could factor out inside the square root, don't take it out yet, I could factor out a 9. That would give me a 1 plus tangent squared theta. And that 9 is a perfect square, so I could pull it out as a 3. And now I have 1 plus tangent squared theta left inside. At this point, you should be thinking, wow, that looks a lot like a Pythagorean identity. And I should probably check to see if I can substitute something in for 1 plus tangent squared of theta. And in fact, you can. 1 plus tangent squared of theta is actually secant squared theta. Don't forget to drop that 3 down in front of your radical. And so if we take the square root of secant squared, we just get 3 secant theta. And that pretty much covers that. If you know that there's some sort of substitution that will make your life easier, and in this case, wow, that looks so much better than the square root of 9 plus x squared. It all simplified nicely, and you're done. This is going to be super helpful in calculus. It's also going to be helpful as we move forward with identities.